This is a question on transportation problem. Wheat is harvested in the Epe and stored in grain elevators in three cities: Ilorin cities, Ogbomoso and Oyo. These grain elevators supply three mills that produce flour, located in Ibadan, Abeokuta and Lagos. Grain is shipped to the mill by road cars, each capable of holding 1 ton of wheat. Each grain elevator is able to supply the following numbers of tons, that is road cars, of wheat to the mill on a monthly basis. So this table is our supply and this table is our what? Our demand. So in our greenhouse, the supply is Ilorin city 285 is the supply, in Ogbomoso 230 is the supply, while in Oyo 180 supply. So the total supply is 700. So here is mill in Ibadan. So the demand is what? 340. Abeokuta, the demand is 240. Lagos is what? The demand is what? 120. And the total is what? 700. The total of it is 700. Due to the board cannot contain it, so I have the question here. I will have to rub it off. So you can make a screenshot of the question. And if you look on the first image of the video, the question has been described on it before this one show. So the cost is from the mill is Ibadan. The cost of the mill Ibadan, Abeokuta, Lagos. So our grain elevator ABC. Remember I told you that the quantity of item is denoted by ABC. So it's 10. That is the cost of it is 10. Ilorin 1 ton cost of what? 10 is like the cost of it. In Ilorin 10, 8 and what? 7. In Ogbomoso 12, 8, 6, 11. Then in Oyo 12, 5 and what? 14. So the continuation of the question is the cost of transporting 1 ton of wheat from each grain elevator source to each mill destination differ according to the distance and gauge system. So these are the cost of the transportation. So the question is determine how many tons of wheat to transport from each grain elevator to each mill on a monthly basis in order to minimize the total cost of transportation. So how can we minimize the total cost of this transportation? So for us to minimize the total cost of this transportation, we have to what? We have to let our decision variable be Sij. I explained on our previous lesson that our I is given from what? From 1, 2, 3. Our J will represent the A, B, C. So these are the costs. So I will have to rub it off so that I can solve the solution. And solution for our first thing is to write down the decision variable of the transportation problem by letting Sij to be the decision variable of the transportation problem. So we have decision variable. Let Sij be the variables of the transportation problem. Remember in our previous lesson, I said our I ran from 1, 2, 3. Our J is A, B, C. Since we have set our decision variable, our next thing is what? Objective function. To formulate the objective function. So if we want to formulate the objective function, you know the transportation cost is what? Minimize. So the objective function is what? We have to minimize the transportation cost. So our objective function will be minimization of the transportation cost. Transportation problem. After our objective function, then what next is what? To formulate the constraint. So we have to formulate the constraint. That is the set of a subject of the linear inequalities or equality. So if you look at this transportation problem, for us to know our equalities, our linear equality is not equal to, because the supply and demand they are the same, so it is a balanced time. So our equalities is what? Equality is to be equal to. So since after we formulate the constraint, we add the non-negativity of the constraint. So we add the non-negative constraint. If you look the value is not negative. So that's why we have add the non-negative constraint. So for now, we have to what? Minimize. We have to minimize z. So minimize z. For us to minimize z, so we have been given our cost here, the cost of transporting one for one ton. So we have been given cost. So our green elevator ABC, we have Ilorin, we have 10. On Abeokuta, we have 8. In Lagos, we have 7. In Ogbomoso, we have 12. In on the main on Abeokuta, we have 6, 11. So the cost of it. So remember that our SIJ from add the non-negative constraint to be SIJ is greater than or equal to what? 0. Because we represent our variable, this one variable as ij. That is our I run from 1, 2, 3. Our j is for what? ABC. So our minimization of this transportation cost is, since our cost we have been given, we have been given Ilorin 10, 8, 7, Ogbomoso 12, 6, 11, then Oyo 12, 5, 4. So in Ilorin we have 10. So 10, then we add it with our decision variable. Our decision variable is what? Sij. It means our I is 1, 2, 3. Our j is what? ABC. Now I have 10x1a plus on Ilorin on B we have 8. 8x1b. On Ilorin we have 7. 7x1c. Then on Ogbomoso we have 12 plus Ogbomoso is what? In another city. So Ogbomoso will now have 12. We have 12. It's now be 12x 2a plus 6s 2b plus 11s 2c. We have done for Ogbomoso. Then last city is Oyo. So Oyo will now be 12s 3a 12x 3a plus 5s 3b plus 4s subscript 3c. So this is our minimization of the cost of the transportation problem. Since we have minimized the cost of the transportation problem, then our next is what? To formulate the constraint. So our constraint, so we have to do for supply. We do because we have been given supply and demand. So supply constraints. So our supply constraint is, we have been given, we have the table for the supply. Ilorin is what? 285. So our supply constraint, we represent it with our decision variable. We have been given Si. We now have x1a plus s1b plus s1c. So the constraint sign will be is equal to, when we are dealing with transportation, is our equalities is equal sign. So is equal to what? So in Ilorin, our supply in Ilorin is what? 285. So Ogbomoso, our Ogbomoso is will be x1b, s2a, s2b plus s2c. So our supply is 230. On Oyo, we have s3a plus s3b plus s3c. Our supply is 185. 185. If you add the supply of Ilorin, Ogbomoso and Oyo, it will be 700 at 700 tons. And if you add the demand also, it's also 700 because they are equal to. So the transportation problem is balanced. It's a balanced time. So that is where we have equality sign. So since we have done the supply of constraints, we have to do the supply of demand. We have to do the demand constraints. So I have to rub this board. So this is the supply of the constraints. The demand constraints. So on our demand, we have Ibadan. The mean of Ibadan is 340. We have x1a plus x1b plus x1c is equal to 340. On Abeokuta, we have 240 demand. We now have x2a plus s2b plus s subscript 2c is equal to 240. Then on Lagos, we have 120 demand of 120 tons of demand. So we now have S3A plus S3B plus S3C is equal to 120. So this is the demand constraint. Since we have gotten our supply constraint already, so demand constraint will be underneath on the supply constraint. Then we now add our what? Non-negativity value of the constraint. Since our value here is greater than, is not negative, we have to have our non-negative value, non-negative, add non-negative. It will not be Sij is greater than or equal to 0. Remember, all these quantity items are being given, they are what? They are greater than or equal to 0. There is not what negative. We don't have a negative value. That's why we have Sij is greater than 0. And our I is what? 1, 2, 3. Our J is what? ABC. So this is how we have to solve this is the solution to the transportation cost of the problem. So thanks you. Don't forget to like, share, and comment.